With the donor harness on the table, we need to find out what modifications need to be made. You can remember I said that when I got this donor harness, I had to cut a bunch of wires that went to a hard shell that went behind the heater AC box that I couldn't access, so I cut them off. I've labeled them. Let's take a look and see what they are. Now on the hard shell side, I have a couple wires. I have this one right here. This goes to the number 1 pin. Remember, that's the keep alive memory. That one's hot all the time. I have this one here. This goes to pin 22. That's the fuel pump enable wire. When this wire goes to ground, it turns the fuel pump relay on. Over on the other side of the harness, I have that same wire, and what it does, it goes through the harness and comes out at the self-test connector right here. It allows you to have a nice convenient place here. When you turn the ignition on, you can ground this wire and you can turn the fuel pump on. It's real good for troubleshooting. I also have this black wire with the green stripe. Remember, you won't always have the same color codes, but this is the main ground. This one goes to pin 40 and pin 60 of the processor, the main ground. This one goes to the hot side of the coil. I'll also have to find where this wire will go to the ignition switch. Remember, the red with the green stripe is coming from the ignition switch. It's hot in run and in the start position. That'll be tied to this one. You have these two wires here. Both of these go to pin 37 and 57 of the processor. It's coming from the e-power relay, then powering up these wires, which in turn goes to all of the actuators. It goes to the injectors, it goes to the idle bypass solenoid, it goes to the EVR that controls the EGR valve, all your actuators. And when they get to the actuators, they will almost always be red. You see one of them's red here, and one of them is looks like black with a green stripe or yellow stripe, something like that. But it goes up here to a splice, and when it goes to the splice, it's red on all of the other wires coming off the back side of that splice. And also you have these two fairly large gauge wires here. These go to the starter solenoid, and they'll be hot all the time. I'll run them to a fuse link, and then they will go to the starter solenoid. And we go a little bit further down in the harness. You have these wires here that were cut off. Now these are the ones that's going to the starter solenoid. This one is the yellow one. This is the one with black with I don't know, orange stripe or something like that. And you also have this one here. This one's going to the underhood light. So I'm going to put 20 gauge fuse links on each one of these, and it will in turn go to the starter solenoid, hot all the time. This wire here, of course, black with the green stripe. This one is going to pin 40 and pin 60 of the processor, the main grounds of the processor. So this one will be tied into that large gauge wire that's near the battery ground terminal. Now all of these wires that I had to cut off are cut a little bit short, so I need to extend them. The reason being is all of these wires will eventually go to the relay box that I made, and I intend to mount the relay box either at the kick pad or maybe under the glove box. And to do that, these wires need to be made a little bit longer. So I'll add about 20 or 24 inches to each one of these wires, so I can put little terminals on them, and then they can be mounted to my relay box. Here on my chalkboard, I have a schematic of the EEC relay and fuel pump relay box that I made. It has a barrier strip that has two 4-pin connectors. And those connectors, of course, are the ground pin that goes to the main ground of the processor. This one here is coming from the fuel pump relay to the fuel pump. Actually, on this model, it goes to the inertia switch and then to the fuel pump. It's mounted in series. Some models, as a matter of fact, I believe the 5-liter 88 Bird has it wired slightly different. Instead, you have a wire that's coming from the fuel pump relay directly to the fuel pump. and the inertia switch is actually on the coil side of the fuel pump right here. This wire that's coming from the EEC power relay that's hot, you know, when you turn the ignition on, and they mount the inertia switch actually in this wire here. It does the same thing. If you're in a collision, the inertia switch goes to an open circuit. That would cause the electricity to not get to the coil of the fuel pump relay. Of course, it turns the fuel pump relay off, which in turn turns the fuel pump off. If you have it like on the turbo coupe, where the inertia switch is in line going to the fuel pump, you have a collision, same thing. Goes to an open circuit, and this main wire coming from the fuel pump relay out to the fuel pump is interrupted, and of course turns the fuel pump off. You have these two wires here. They're the 37 and 57 pin that goes hot when the power relay turns on, and of course that goes to all the actuators, as we said before. This is the pin 22, which is the fuel pump enable wire. When that wire goes to ground, turns the fuel pump relay on. This is the red with the light green stripe that goes to the ignition switch. So when it's in the on position or in the start position, that goes hot. That turns on the EEC power relay, and it also, that wire goes to the positive side of the ignition coil. And then you have these two leads here that are hot all the time. They will go to fuse links out to the starter solenoid. Okay, we've accounted for most of the wiring that's needed to interface the EEC wiring with the car itself. We've established a battery ground connection, hot all the time for, you know, both of your relays. The ignition switch wire, and we'll still have to find that wire coming from the ignition switch. We need another wire that's coming from the ignition switch, the gray with the yellow stripe, that will go to the oxygen heaters. We still need to find that. The starter solenoid wire will still need to be obtained. One, the wire coming directly from the starter solenoid that's coming, you know, from the ignition switch, that goes to the TFI module, and also that wire between the ignition switch and the neutral safety switch has to be hooked to pin 30. That'll still have to be found. The pump to relay wire will have to be found on this car. It's down there in that toe board area, so we'll have to splice into that once we find it. And of course the pin 22 and the EEC power relays wires 37 and 57 we have already established. Now there's a few more wires that we will need to interface. On this model, it is not always necessary. I want to find the tack wire. Now on this car, it will be green with the yellow stripe, and that's coming from the negative side of the coil. I need to find that wire, or have it where I can access it to go to an aftermarket tachometer. Understand, on this turbo coupe, this was a 4-cylinder model, so the tack will not work with the 8-cylinder. It's calibrated for a 4-cylinder engine. So I'm going to get a aftermarket tack, and I will need to have that tack wire. Now the VSS has 2 wires. I don't need to have that for sure to make the processor work. For the most part, the processor is taking vehicle speed signals, and it's doing various things. It's determining certain emission type functions. It also is used so when you're decelerating going down a hill, it sees that as high vacuum, very low load, but because it's going at speed, it knows that it needs to decelerate. And what it'll do, it'll change the strategy of the injectors. It will nearly shut the injectors off, which will give you better engine braking. It's a little bit better for emissions too. I need to have those wires hooked up for this car for the simple reason that I have an electronic speedometer. To make the speedometer work, I need to have them hooked up. Well, through the normal wiring of the car, my speedometer should work because I'm not going to tamper with those wires. But because I can access those wires as soon as I find them, I will likely go ahead and tie those into the processor as well. Okay, on this project, where possible, I will try not to tamper with the body harness itself. In other words, If there's wires that I don't need that's on a hard shell, I'll just simply leave them as an open circuit. If there's wires I need to hook into, instead of pulling, the terminal out of the hard shell and sticking it somewhere else, I will just simply graft onto that wire. I will splice into it, maybe make a solder connection, and have that go to my donor harness. The idea is that if you start pulling too many wires out that look like they're unimportant, it doesn't look like it needs to go anywhere, you'll come find out it's going to a headlight or something, you didn't even realize it, and you're going to have more trouble with the troubleshooting. So it's best to try to keep as much of the body harness untampered with as possible, then graft in any extra wires that you need to go to your donor harness, and I will try to do that as much as possible. Also, it will allow me, if at a later date I want to put this right back as a turbo coupe, put the 4-cylinder engine back in, I should be able to just put the original harness back in and it'll work just fine. Any wires that I grafted onto it can just be cut off or just left as an open circuit. So let's go back over to the table and we're going to start making some modifications to that donor harness. Okay, we'll start with a little extra wire that I'll be adding, and this is an 18 gauge wire, and I'll strip off a little bit more maybe than a 1/4 inch of it. There you go. And then I do the same to the pin 22 wires that's coming from the hard shell and the one that goes to the self-test connector here. And take my butt connector here. What I'm going to do is I'm going to add my new wire to one side, kind of twist them together there, then put the butt connector over it, crimp it, then put the other wire in on the other side, and crimp that side. There you go. That's one taken care of right there. And I'll put a terminal on this end a little later, which will go to the relay box. All right, let's try one of the larger wires. How about this yellow wire that's going to be hot all the time, that's going to go to the starter solenoid. I took and made me a longer piece here. My extension, I'm using 12 gauge wire on this one. So I'm using a yellow butt connector. I've already pulled back insulation a little bit more than a 1/4 inch worth. Put my butt connector on this side, seat it, crimp it, and my new extension wire on the other side. Again, pull the insulation off, go in there, crimp that side. All right. You always want to use the same gauge wire or even the next size larger when in doubt. Alright, this particular type of butt connectors uses a shrink tubing that's mounted right to the connector, so we'll shrink that down. Okay, I'll use my little butane torch here. Start a fire going. And we'll shrink this tubing up here. Okay, these are all done now. Now the pin 1 keep alive memory and the pin 22 the fuel pump enable, I used 18 gauge wire on that. I used 12 gauge wire on the two hot wires that are going to the starter solenoid, and I used 14 gauge wire on all of the other terminals. Okay, now let's do those fuse links, those 3 wires there. I'll cut these little rubber pieces off here, and I'll strip these wires back about 1/4 inch. Okay, now here's some 20 gauge fuse link wire. Now how fuse link works, it's designed to carry the full load of whatever you're running. However, if you have a short circuit, the wire will just simply burn up and melt. Now you can use fuse link. I'm going to use 20 gauge for each one of these. You could also use an inline fuse holder. I would say use maybe a 30 amp fuse if you were going to use inline fuses. I'm going to use fuse link wire, and just simply crimp each one of these in place. Now on the other side, I will just simply, wrap these 3 wires together like this and put them in a single eyelet terminal, and that one eyelet terminal will go on the starter solenoid. Now understand, because I'm running 3 individual wires, each circuit will be protected by its own individual link, but we'll tie them all together at the starter solenoid through this eyelet terminal here. Now you remember that this harness had already been cannibalized a little bit. Somebody had already taken the TFI wires off, so I had to find another car to get the TFI wires, and we'll have to graph that on here. And it's mainly just a color code to color code situation. It's 6 wires plus the shielding wire, so all 7 of those wires need to be hooked up. There you go, and I think I'll wrap the whole thing up in a little bit of electrical tape. Okay, that don't look too bad. And then the entire harness all the way to the TFI will be covered up in the convolute tubing. Now I looked at the oxygen sensor harness, and all I needed to do was to add a new ground wire, terminal that had been cut off before. And you might remember there was actually 2 ground wires on it, or it seemed like it was 2 grounds. Well, I took a look at the other one, and where it went was up to the hard shell, and I looked at the mating part of the hard shell, and there was no wire there. So that little extra ground or whatever it was for likely a different application than from this 5-liter bird, maybe something on a Mark 7 perhaps. Now the injector harness is probably okay just like it stands. The hard shell for the ACT, or the air charge temperature sensor, on an Explorer intake, I had to relocate where that sensor is going to be. So therefore these wires may need to be extended. We'll see a little later on. Other than that, I believe this harness is okay like it stands. Now we're almost done with the donor harness here, but remember I said earlier we still need to find connections for some ignition wires, VSS. I want to have a connection for my tachometer, and we still need a lead that goes from the starter solenoid and to pin 30 on the processor. Well, it just so happens that this donor harness has 2 hard shell connectors right here that coincide with 2 hard shell connectors that are on the Thunderbird. Unfortunately, the wires are different and therefore different applications. But it just so happens that the black hard shell and the black hard shell body harness happens to have 3 wires exactly in the right place. The red with the green stripe that's coming from the ignition switch, that is on here. The red wire with the blue stripe that's coming from the starter solenoid, that's on here. And the wire that's used to go to the pin 30 position on the processor, remember that's the transmission load sensor wire, and that's between the ignition switch and the neutral safety switch, that's on here, and it's also in the correct location. Now the gray wire also has the tack lead that I need and the 2 VSS wires. However, they're in the wrong location, so they'll have to be repositioned, and the other wires that won't be used will simply be taken out of the harness. So once I do that, I think I'll have just about all my connections made. There is one more. There's that gray with the yellow stripe that's used for the oxygen sensor heaters. Well, that's on this hard shell, but there is not a mating connection on the 2 hard shell connectors that are on the body harness. However, the gray with the yellow striped wire is on the body harness, it's just simply on a different hard shell. So therefore I will have to graft a separate wire for that. As well as, you know, the main ground wire that's going to the battery ground connection, you know, that goes to pin 60 and pin 40, that will also have to be grafted onto that ground wire that's going to the battery. So we know we have at least 2 wires that will have to be grafted under the hood, and inside the passenger compartment, at least the 1 wire that's going back to the fuel pump will have to be grafted in to this donor harness and to the relay box that I made. Now, while I'm changing the position on those hard shells, I want to do one more thing. I want to add the 2 wires that will be needed at a future time in case I want to change this over to mass air. Remember that pin 9 and pin 50 go to the mass air sensor if it's equipped. So I'm going to add those 2 wires to the hard shell now, and so it'll be ready when the time comes. Now, to do that, you have to take this little plastic retainer out the bottom of the hard shell. I usually just use a pick tool and get underneath of it, and you can just kind of just carefully work the ends here, and it eventually will come up, and you can remove that. That's so you can get to the tabs and release the tabs if you need to. Now in my case, I'm adding wires, I'm not taking them out, so I don't have to depress those little tabs. However, if you need to, you can take a little pick tool and you go right down in there past beside the terminal and release the little tab and then pull the wire out. In my case, I'm just adding wires. So I'm going to add, you know, 2 little wires here I have this little kind of tan color one. I'll put that in the number 9 position. So remember how this is numbered here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I will just take the wire and put it right in there. Okay, now I'll put number 50 in, and that one goes in this location right here. And we'll put the plastic insert back into the hard shell. Just like that. Now that I've added the 2 wires to the 60-pin hard shell for the mass air sensor, I thought, well, this is a good time to go ahead and add the 4 wires that are needed for the mass air, have it go out under the hood to some hard shell connector, so it will be ready when the time comes to plug one in. So I thought, well, what's out there that has a 4-wire harness, has a male-female connection, and it's readily available? So after thinking about it for a while, I came up with this. a trailer wire harness. It seems to be the perfect thing. You have fairly stout wires. I believe these are about 16 gauge. You have a male-female connection that has nice, good terminals. You'll have very little trouble with resistance on those. They're nice and big. You have a short section here. This could easily go to the hard shell connector for the mass air itself. And then this other piece has about a 4-foot long wire, and this could be tied into the EEC harness. I figure, well, you have, one bare terminal here that could go to the ground, have the next one go to pin number 9, have the next one go to pin 50. Those are the two connections that we added. And then the last one be the hot wire, which would actually go to the pin 3757 on the processor, which in turn comes from the EEC power relay. So I looked at my harness, and of course I have these, the two wires that we added, and the ground and the hot wire, of course, have already been, I've already put the butt connectors on them, these extensions here. So I decided, well, what would be better, instead of, adding another butt connector or something like that, I'll solder those connections into place. So we'll do that now. We'll start with the ground connection. Remember, this is black with a green stripe. This goes to pin 40 and pin 60. And I've stripped back a little bit of wire here for the white terminal, which we'll use as the ground. And I'll make a good mechanical connection on this by spinning it around all the way around that part of the wire that I've taken the insulation off, right here. Just like that. Now we want to solder that in place. Okay, I'll warm up my soldering gun here, and I'll take some solder and tin the end. That'll help transfer the heat. And remember, you have to use rosin core type solder. That's the only thing you can use on electrical connections. Now I'll take the soldering tip and put it right on the connection to warm it up. You let the solder flow right into the connection, just like that. Perfect. Now I'll do the hot wire. Remember, this is going to the pin 3757. Wrap the wire around the area that I've stripped off and solder that one. Now the brown wire to the number 9 pin. And the yellow wire will go to the number 50 pin. There you go. Heated up the shrink tubing on 2 of the connectors and put electrical tape on the 2 solder connections. As you can see, I've reinstalled that lower main harness. Most of these wires, about 95% of them, go to the anti-lock brake. Now there's a few things that won't be reused. For instance, this wire here, which went to the ride control. I'm not going to reuse that. I certainly have the wires going to the front wheel sensors. Those are plugged in. I had the self-test connector for the turbo coupe engine. I didn't cut that off. I just simply won't reuse it, and I have it hidden up underneath the master cylinder. I'm trying not to cut any of the original wires off. If I'm going to add anything, I will add a wire, but the other ones that I don't use will just simply be left as an open circuit. Now you can't see it, but I have the short harness that goes to the oxygen sensors. Remember, I had to add a ground wire to them. And be sure that you have the right and the left oxygen sensor hooked to the correct hard shells. If you have those backwards, you're going to wind up having a drivability problem. And you can see I've added the ground and for the oxygen sensors, plus the ground to the firewall right here. You can see I've added the injector harness to the engine. Here's the two salt and pepper shaker hard shells. You have each hard shell on the individual injectors. They're not numbered, but normally when you lay the harness down, it's self-evident where each hard shell goes from the location of the wires. You see the hard shell here for the IEC, or idle bypass solenoid. Here's one for the throttle position sensor, ECT and canister purge. And over on this side you have the ACT sensor and the single wire that goes to the temperature sending unit for the gauge. There's another a little bit longer wire that goes down to the oil filter area, and of course that's going to the oil pressure sending unit. Now I have a little bit of a problem with the length of some of these hard shells. This intake of course is an Explorer intake, and the Explorers had EEC5 electronics, and they had distributorless ignition. They did not have a distributor. This car, of course, does have a distributor. The normal location for the ECT sensor is here on this heater hose tube, and the sending unit for the gauge is normally here on the left-hand side. Now, unfortunately, I cannot put the ECT sensor in its normal stock location because it's so large it actually hits the distributor. So I just simply took those sending units and swapped them out. It should work fine, but the problem is the wires are too short. The single wire for the gauge sending unit, you can see, won't reach over to the right-hand side. And the ECT sensor, which needs to go over here on the left-hand side, you can see it's not long enough. On top of that, the ACT sensor normally goes right here. The sensor is actually on the lower intake in this location. But the Explorer intake does not have the ACT there. It's normally in the intake tube of the air filter assembly. So I decided, well, I can relocate the ACT sensor in the intake plenum right here. It's kind of like in the front of the intake plenum when it's installed. Again, it will not reach it. So I thought, well, all I can do is cut the wires, add a little extension in there, you know, and put two butt connectors on either end, which I'm not real keen on that. So I thought what would be better is to simply find another donor harness, and I happen to have one. It's from a Taurus, I think, and take the hard shells from that harness and make sure I have about 12 or 14 inches of the wire. So what I'll do, I'll just simply, you know, cut these wires at the hard shell that's on there now, add however much of the new wire from the donor hard shell so I can make them reach the different sensors, and, you know, put butt connectors on them. Shrink tubing should work just fine, and I'll do that in a few minutes. Now, you remember in an earlier scene I said that there was about 8 connections that hook the EEC harness to the car itself. You have some secondary wires too, that's going to instrumentation and VSS, that type of thing. Incredibly though, on this project, only 3 connections were added to the body harness itself. The body harness was essentially untampered with. Only 3 connections or 3 splices were made. One is in the right-hand kick panel area. Had to add a wire which is going to the fuel pump. I added a wire here in the firewall area. This is going to the gray with the yellow stripe wire. It's coming from the ignition switch, and that will be used to power up the oxygen sensor heaters. The third connection is a large gauge wire here at the battery ground, and of course that will be going to pins 40 and pin 60 on the EEC harness for the main grounds of the processor. The other connections that I needed to make were all found on those 2 round hard shell connectors that are coming from the instrument panel on the inside. And I did not disturb those wires at all. I made all of the modifications to the donor harness to mate up with those wires. And I would say now let's go over to the other side of the body and we'll start installing the EEC harness. Yeah, I have to get all these little extra wires that I added all down into the passenger compartment here. And that's about it right there. And of course, here's my harness here, which will be used at a later date for the mass air sensor. Now I'll put the boot back on it, but just in case I have to slide the cable in and out just a little bit, I'll leave that off for now. Okay, let me just kind of fold up this extra wire and stick it right here for now. And let me take the rest of the harness and we'll start stringing it across to the other side. Okay. Now let's go back and start making a few connections. Okay, if you were going to retain air conditioning, you would be using this hard shell. This is going to the cycling switch. In other words, you would have your dryer would be mounted in this location and the cycling switch would be right on top. You have this long wire going to this hard shell, which goes to a relay, and that's for the wide open throttle compressor cutout relay for the air conditioning. You have these two hard shells, and they go to two solenoids that's used to operate the air pump valves. You have this hard shell that's going to the EVR or EGR vacuum regulator, and you have this short little wire here, and that's going to the under hood light, and I will reuse that. All right, let's go a little further down. You have the two salt and pepper shakers, and plug those in. And you have this hard shell, which goes to that short harness that goes to the oxygen sensors. I'll have to reach down there and plug that one in. Now we have a bunch of wires on hard shells here. I won't worry about those just yet. I'll wait until the dash panel goes in and we'll make those connections. Let's go a little bit further down. Okay, I'll put the coil hard shell connector on. I have the fuse link wires that were added to the EEC harness, and I'll put that on the starter solenoid. And I'll just put the nut on loosely because we have a few more things to go on there. And I need to come up with a connection here for the main battery ground. Let's go inside the car now and see the wiring that will be needed on the inside. Here is where I spliced in the new wire. On this model it was pink with the black stripe. That's the one that's going back to the fuel pump. Wow, it's kind of hard to know where to start. Well, I have the relay box and it's labeled, so we'll just start right here at the top, and that's the ground wire. Remember, we have the wire that's going to the pin 40 and pin 60 connection, and we'll put that one on first, right here. The next one is pump out, and that will be the new wire that I spliced into that pink with the black stripe. The next two connections are the pin 37 and 57 from the EEC harness. The next connection at the top is the pin 22 of the processor. That's the one that's used to turn on the fuel pump relay. Next, we have the red with the green stripe that's coming from the ignition switch and the positive side of the ignition coil. Now, the last two connections are the fuel pump relay on top and the e-power relay on the bottom. And what I'm connecting to it are those two big wires that are going to the starter solenoid that have the fuse links on it. Also, there's one more connection to be made here as well, and that is the number one wire on the processor, which is the keep alive memory. It needs to be powered up at all times. Now, a little tip for you. If you were running two pumps, now some applications, a lot of people run two pumps, especially if they're running nitric oxide or something like that. If that's the case, this top wire going to the fuel pump, you might change that from a 20 gauge to an 18 gauge fuse link. Otherwise, on this model, on this particular project, I'm going with the 20 gauge fuse link. Now let me move both of the wire harnesses up against the right hand fender well area, and I need to bolt the case ground to the original ground bolt right here behind the carpet. Okay, I can put the firewall boot back on the harnesses, and then I can put the heater AC box back in the car. Okay, I did replace the heater core. It's just a matter of taking the 4 screws off this top plate, pull the heater core out, put your new one in, put the 4 screws back in, and be sure this vacuum hose is going through the firewall boot there. Now, the heater AC box is held to the firewall in 5 places. You have bolts that go through these 2 locations here. You have a bolt down here at the bottom, and you have 2 studs in the front that go through holes in the firewall. Now I'll go ahead and put the heater box in the car, and by the way, sometimes you need a little bit of help to get those studs lined up with the holes in the firewall. Now be sure you get that vacuum hose through the hole in the firewall. Okay, let me get one of the bolts started here. Now be sure the carpet didn't get stuck underneath or behind the heater box as you were putting it up. And we've got those 2 bolts in. Now I need to put this slightly longer bolt in down in this location. Now I like to put a little bit of caulking compound around the washer part of the nuts, you know, keep from having a water leak, and then go ahead and install them. By the way, make sure your vacuum hose came through all right. Alright, now I'll go on the inside and finish tightening up the inside bolts. Yeah, that's it. Dash panel is next. Now, removing and reinstalling a dash panel is not that difficult, but there are so many things that have to be unhooked and rehooked that it makes this kind of job a challenge. So let's go over the dash while we have it on the floor here. We'll look over some of the harnesses, the steering column, show you what you're up against. Here on the left side, we see the main wire harness that's coming from the dash panel, going through a hole in the firewall out into the engine bay. And earlier in the video, you saw most of these connections here. This one, of course, is going to the windshield wiper motor. These two hard shells went to the harness for the turbo engine, and some of those connections will be reused by changing the pin position on our donor harness. Wires coming from the ignition switch, some wires going to the VSS, a few other things like that. Further down the harness, you have this hard shell that's going to the headlights and parking lights, horn. You have this fuse link here, which went to the starter solenoid. The smaller wire, of course, goes to the starter solenoid. It's coming from the ignition switch. Actually, it's coming from the neutral safety switch. These wires here go to the alternator, and this short harness here goes to the windshield washer reservoir. Moving over a little ways, and you see the wires that's going to the steering column. This is going to the ignition switch. This is going to turn signals, windshield wiper. Here's the hard shell that's going to the brake light switch. And these two hard shells are going to the instrumentation. Here in the center of the dash, you have lots of hard shell connectors. They're going to the radio, AC heat control head, blower motor switch, rear window defroster, or heated backlight as Ford calls it. Lots of connections here. Moving over to the right hand side of the dash, you have two big connectors here. One's going to the blower motor and one's going to the blower motor resistor. You have several hard shells here, and they mate to hard shells that are in the kick panel area on the right hand side. Now, the dash panel is bolted to the firewall by 6 fasteners. You have a screw here near the left-hand speaker, one right in the middle of the top of the dash, and one at the right-hand speaker. You also have a bolt here on the lower left side of the dash and at the lower right of the dash. Now, there's one fastener people tend to forget about, and that is the stud that's coming down here in the steering column area. That ties into the brake pedal support, and you have a nut that holds the two together. Now, the brake pedal support has 4 studs that the steering column is bolted to. Sometimes there's an added brace that's coming from this stud area. Here's the steering wheel rotation sensor. It's part of the ride control. And don't forget about the pinch bolt that goes in this location. That ties the steering column to the rack and pinion. Leave that bolt out and you're in for a big surprise. You start going down the road and turn the wheel and the car doesn't turn. I flipped the dash around so you see the back side, and you see tons more wire connections, vacuum connections. There's at least 6 relays here. There's 2 more relays in the car itself. It's going to all of the many accessories that the Turbo Coupe has. I just want to point out a few of the connections though. Right here in the middle of the dash, you have this hard shell. Now, this one goes to a mating hard shell that's coming out of the floor pan right near the shifter. That goes to the neutral safety switch, backup lights, VSS, all of those connections that are down there near the transmission. Very important one to hook up. You see this little hose connection here. It goes to a couple of these kind of flexible tubes. That goes to a hole in the heater box where the floor ductwork is. So don't forget to hook that one up when you put the dash in. In the steering column area, you can see that stud real easy from the back side that ties the instrument panel to the brake pedal support. And of course, you have some more hard shells that hook to wire looms that are on the left-hand interior of the car. Now I think you'll find you need some help putting the dash in, because you have to lift it up, get it over top of the shifter to clear that. As you go in with it, you have to feed this wire loom through that hole in the left-hand side of the firewall. Then when you get close, then you can hook all your hard shells up. You know, make sure you put that hose on that lower floor vent, and then get it up to the firewall. Take your fasteners, you know, bolt the dash in. Then I would say you could put your steering column in, and then everything else that's left after that, your instrumentation, your heater control head, radio, things like that. Ta-da! I've got the dash in. That's right, I cheated a little bit. I installed the dash off camera. But there's really nothing much to show. You just have to take your time. The biggest problem is getting that wire loom through the hole in the firewall on the left side. You have to go just a couple inches at a time. If you have someone helping you, that's a good thing. Then once you get the dash up against the firewall, you know, put your fasteners in, tighten them up. Don't forget that stud that's above the steering column. Then you have to put all the hard shells together, and there's a lot of them. I usually start here on the right-hand side, start plugging them in, you know, work my way all the way over to the left side, and I put the park and brake release handle on last. Now for now, I'm not going to install the radio or the heater control head because I want to get the engine running first. If I have any electrical problems, I'd like to have all this trim off so I can access the wires. Now I did have to hook up that hard shell that's going to the neutral safety switch. And I would say the next thing we need to do is to put the steering column in, you know, and hook the hard shell to the ignition switch, and then put the gauge cluster in. And don't forget the pinch bolt. Back under the hood, I've got the you know, the wire loom that was coming from the instrument panel plugged back into the original hard shells that you saw earlier in the video. You know, going to the headlights, going to the alternator, going to the starter solenoid. In fact, I have all of the fuse links hooked up here, so I installed the positive battery cable that's bolted up to the starter solenoid as well. Now the hard shells that were coming from under the dash, remember I said had some wires that we needed to hook to the donor harness, and by taking the gray and the black hard shell of the donor harness and moving some wires around, I was able to get the 2 wires that I needed for the temperature sending unit and the oil pressure sending unit. I have it going into this hard shell. As a matter of fact, I found a mating hard shell from that Taurus harness that I had, so I could accommodate that. On the black connector, I have the red with the green stripe that's coming from the ignition switch. I have the red with the blue stripe that's coming from, you know, the starter solenoid. I have the brown with the white stripe, which is coming actually between the ignition switch and the neutral safety switch, and remember that's going to pin 30. On the gray connector, I have the 2 wires that's going to the speed control, or actually the speed sensor. And on this hard shell, I have the gray with the yellow stripe that I tapped into, which is the wire going to the oxygen sensor heaters. Here at the vacuum tree fitting, I have a 180-degree vacuum hose that I found. It's going to a tube that's on the back of the Explorer intake. I have a small hose here that goes to the inside of the car, which goes to the boost gauge on the instrument panel. I have a short hose here going to the MAP sensor. I don't have a bracket for the MAP sensor yet, so I just have it hanging up here. And remember, this is for a speed density car. If you had a mass air car, this would be a barometric pressure sensor, and it would not have a vacuum hose on it. I have a vacuum hose going to the fuel pressure regulator, and I have a vacuum hose that goes to the right-hand fender well area to a check valve. And from the check valve, there's a vacuum hose that goes under the fender to a vacuum reservoir, and the other vacuum hose goes from the check valve to the heater AC box. Now, if you were going to retain speed control, the EGR system, and the air pump system, there would be vacuum hoses going to those components as well. While we're on the subject of vacuum hoses, I want to show you a few modifications I had to make to the Explorer intake. Once we do that, we'll install the upper intake and finish wiring up the engine. Now, on the bottom of an Explorer intake, you normally have two vacuum tubes in this location, little 90-degree tubes, and they hook to hoses which goes to the PCV valve. Now, unfortunately, I had a little clearance problem there. The aftermarket valve covers I'm using are a little bit taller, and they interfered with those tubes. I could have bought a phenolic spacer to go between the lower and upper intake. That would probably fix the clearance problem. But what I decided to do was to cut them off, drill them, tap them, and put two pipe plugs there. Now, that made me change the way the PCV valve is hooked up. So I had to come up with a couple little, connections here and hook the PCV valve to this tube here. Now, here's the little rubber grommet that normally goes down into the lower intake. If you had a GT 5-liter Mustang intake, there would be a little, what we used to call a Brillo pad. It's a little oil to vapor separator, little mesh screen that goes down into the lower intake. The later Explorer intakes have a different baffling system there, and apparently they don't use those little Brillo pads. Over here on this side, you see the two small tubes that go to the PCV valve heater. I've done away with that. They can just be left unplugged. I do have a vacuum hose connection here. I have a nipple on that and one in this location as well. Now, this tube is left open because that's going to that large 180-degree bent vacuum hose that goes to the vacuum tree. Also, you'll see this is where I decided to mount the ACT sensor. I drilled into the side here, tapped it, and mounted the sensor in that location. Now, I have a 60mm Mustang throttle body bolted on because the 65mm throttle body from the Explorer, which I want to use at a later date, does not have a compatible linkage. It's not designed to hook up to the TV cable that's used on this transmission. So I just have the Mustang throttle body on for now. I've added a IEC, or idle bypass solenoid. Actually, this is the one from the Turbo Coupe engine. I have a new throttle position sensor on here, and be careful when you install these. They have to be indexed right. If you don't have them on there exactly right, you won't be able to open the throttle. I've mounted the bracket for the throttle cable and the TV cable for the transmission. Normally you would have a EGR bolted here. I'm not going to run EGR, so I just simply have a block-off plate. You also see two nipples here. These are going to the EGR cooler. Again, because I'm not running EGR, they will just be left blank.